What is artificial intelligence? Welcome to this short course where we try to make you understand concepts at a very simple, at a very basic level. If you've wondered what the terminology means and you have done some Google search, you probably have come across dozens of different definitions, if not even hundreds of different definitions from different companies out there. And they're mostly right. They all have their own unique angle, unique way of describing what the terminology means. So let's go ahead and start with our definition. And we promise you that at the end of this very short presentation, you will walk away with a really good understanding of what the terminology means. And we'll put you on the right path for you to continue your growth in this area. So let's start with the definition. Artificial intelligence is a very specific type of technology that attempts to replicate a human thought process. It builds its intelligence by absorbing materials and observations, and it uses this intelligence to make important forecasts and inferences. This is my definition. My name is Nadeem Ogle, and I'm relying upon this definition really to make a few points come across. It's a type of technology, it's a tool. It's not an end all and be all, it's just a tool. Just like we deploy any other tool in our decision making process, this is also just one tool. This is an important point for us to understand. Another point is that it builds its intelligence by absorbing materials and observations. So we are supposed to have provided the right material, and as we go explain in this entire presentation, you would see what some of the concerning points might be. So with that, let's go ahead and continue. The best way to understand something is to really apply a real life problem. So let's go ahead and start with the problem. Let's say you're a consultant and a company has hired you to help them understand why they have such a high employee turnover, such a high attrition rate. People just don't stick around. They say that more than 10% of their employees quit every year. Interesting problem, right? So let's go ahead and see how we would use this. Forget about artificial intelligence for a moment. Let's just say that in the real world, you're a consultant, you come on board asking you this question, and you're trying to understand, you're trying to help them with this analysis. So what are the impacts? Obviously, if they don't address this, if they let the situation to continue as it currently is, so they're always looking for more people, and they're investing obviously in training these people. So once they come on board, they have to train them, right, and how they're supposed to work, how they're supposed to operate and function and perform within the organization. And as soon as they become proficient, they quit. This is an expensive process, and they really want us to help them put an end to this. What else are the impacts? They're always late in delivering their projects because people are just not skilled in what's needed to be done. Again, when, as I said earlier, if the proficient people are leaving, then the remaining people that don't always necessarily have the skills to perform, to get the job done. They need to constantly deal with quality issues. As this is more of a corollary to the previous point, that if people are just not skilled, they may be able to perform to kick the can down the road, but then again there may be quality issues. So the problem is not resolved. Just comes back to you for further resolution. And the morale, obviously, of the remaining employees is very low. They resent having to pick up extra work all the time. So their customers are beginning to notice this. They prefer to work with the same person every time, and yet they've expressed their frustration that why do we see new faces every time we come in? Again, so this is not just your internal observation. The thing is now getting out of your company now, and outsiders are now beginning to take notice that you do have a very high employee turnover, and as a company, you really want to address this. So again, why is it important for them to be able to solve it? Employees who have learned how we operate, they are in a much better position to help us maintain our standards. So this is again you interviewing them, and they're telling you why this whole search, this whole quest is really important. So they're saying that good employees, qualified and well-trained employees, allow us to operate in a better position, and that's absolutely the case. And they're saying that our customers prefer to build their history with a specific employee, and they want to continue to work with them every time they come in. Again, we've already heard about this problem. And when an employee leaves, it causes disruption to the team and really delays our projects. And when an employee leaves the company, it impacts the work environment. Clearly, We understand what this is. So what happens? We say, okay, let's roll up our sleeve. Let's go ahead and get moving. Let's try to figure out what's going on. And you ask them to give us your data, give us your information, so we could start working on it. They give you an Excel spreadsheet. It looks like this, just these 7 or 8 columns, and just there's a they just have 13 employees in this sample spreadsheet, and again there will be a lot more, but let's just start off with this. So again, we're trying to explain what the process in real life would look like. You're handed a piece of data that looks like this. So you say, okay, great, I've got something to start with, as against having nothing, right? So let's go ahead and get started. So you put on your consulting hats. You say, fine, I know how to start this process. So you say, okay, fine, where's my highlighter? You highlight some of the rows. So you highlight all the terminated rows in the last column, the status column. So you're looking at the spreadsheet that has active employees who are currently on the payroll. They're working for the company, and you've got terminated employees who are no longer there. So you're trying to understand, trying to look at this data and see what's unique about those people. A few things, perhaps, just if you spend a few minutes, they would perhaps jump out at you. You would see that in the reports to column, this number 25795 appears for 3 of the 4 people who are terminated. So if you can just follow this whole spreadsheet here. So James Madison, employee number 41313, was hired on 10/28/2011 as a phone support person. He's level 5, and this person reports to 25795, who, if you look at the spreadsheet, is William Henry Harrison. Okay, so we made an observation, and it turns out that 3 of the 4 people within the spreadsheet who have moved on, they work for William Henry Harrison. So clearly there's something. Maybe you've stumbled onto something. Maybe there's a unique factor. But is this the only factor? Clearly, there is somebody else who works for William Henry Harrison. If you look at Zachary Taylor, employee number 12, employee ID 49779, row number 12, Zachary Taylor, also refers to the same person, and yet this person is active. Been here for as much amount of time as the other employee, and this person has not left. And yet we have got somebody else, record number 6, employee 29786, John Quincy Adams, who has been terminated and who reports to somebody else. So again, you looked at the data. You said, yeah, I can see some relevances, but I need more. I need to get more information. So you go back to your customer and you say, you know what? Thanks for giving me what you've given me, but yeah, I need some more. I need some more data. Give me some more. They said, okay. So far we've given you these fields. Fine. Let's give you something else. Let's give you their education level, the highest degree they have earned, and how many years of experience they had when they began the job. Again, some more insights, some more useful insights. You get to work, and now you're getting some more insights, some more understanding about why people are leaving. Again, that's not enough, so you ask them to give you some more. They said, okay, fine. In addition to that education, which is highlighted in green, let's also give you the salary, how much they're making at the job, and how does the salary compare within the market space. So is it 100% of what the marketplace is, or is it 80%, 60%? So they're underpaid compared to the market, they're overpaid compared to the market. So just a basic comparison. Again, very useful information, right? Useful metric. And you're saying, yeah, I could work with this. You go to work, and then you come back and say, give me more. I need some more insight. And now they give you some additional fields. Does the spouse, the fields in yellow, does the spouse also work for the same company? Yes or no? Also, how about the last salary raise performance rating? Did they get a good performing score or a bad score? How much raise did they get? What was the date of the last raise? Maybe the date when they left the company. So again, as you can see, we were given a very basic, the one on the extreme left hand side, that's the basic level of information we were given. And you said, I need some more data. So they keep giving you more information, more information, more information each time they come back to you. And now they've given you a lot of this data. So imagine now you began with 7 columns in your spreadsheet, and now you have got maybe, I don't know, 18 or 19 or 20 different columns. A lot more insight. Imagine now looking at this and trying to figure out what is happening. And let's assume for a moment that you have to wade through hundreds, if not thousands, of employees. How would you do it? In the initial example that we said we only had 13 or 14 employees to go through, and we were able to pick on one point. The 3 of the 4 people who were terminated reported to this one person. What if there is something else at work? How would we possibly do it? So that's the question. So initially we just said we're trying to gain more insight from the data, but how do we really do it? That's the challenging part, right? So what are we looking for? We're trying to ascertain which variables, when present in specific fields, are likely to result in a terminated employee. Just like we said in the initial example, that those who reported to a specific employee, to a specific manager, they're likely to be terminated. So again, that's one factor that we stumble upon. Again, now that we're looking at 18 or 19 different fields, there could be perhaps a lot more attributes as well. And how do we rephrase that? Which variables or which values of those variables, when present, are likely to reverse the status of termination? Okay, again, same question asked in two different ways. So let's continue. So let's introduce the topic of correlation. What is correlation? It's a mutual relationship or connection between two or more things. Or it's a quantity measuring the extent of the interdependence of variable quantities. Let's look at the examples here. So imagine all the 18 fields that we had. So when you're trying to ascertain the correlation between that data set, you're trying to compare every field with every other field. So here's something in action. Again, it's a different example here, because these 10 fields on the left hand side on the y-axis, and we're comparing them with the same 10 fields on the x-axis. Clearly, if you look at the diagonal, if you look at the red lines along the diagonal, if you follow the mouse, you can see that these are perfectly correlated. So what does red mean? Red means they're perfectly correlated. That means the two fields have behave exactly as expected. And it's obvious, right? A field will always be correlated with itself. Clearly and understandable. And what's the converse of that? Converse of that would be the blue field, which is the exact opposite end of the spectrum, and no correlation was found between these two fields. So again, in case of a red field, if something happens to one field, we can pretty much guess with a very high level of confidence that we can predict the value of the second field as well. In the blue, we have no idea, because we don't have the confidence to say that there's any correlation between the two fields. And all the fields which are between the extremes of red and blue, there's a degree of correlation. So as the field moves from blue to a red, we're increasing the level of correlation between those two fields. And conversely, if the field is going from red to blue, we are decreasing the level of correlation. Okay, all right. So we understand what this means. Great. So now that we understand that we have given a data set, now that we understand that we're trying to figure out that in the entire matrix of what we were given, we're trying to understand which columns contribute to the status column, or status of terminated or active, which columns contribute. So now we understand how this works. Great. So let's now see if we can take this quiz. True or false? Let's give you some facts. In summer months, ice cream sales go up. We live in this world, so we know that we can understand with this statement of fact that yeah, ice cream sales do go up in summer. And the statement of fact: in summer months, more people drown while swimming in the ocean. Yeah, that's perhaps true as well. So, can we then draw a conclusion that or ice cream causes people to drown? What do you think? Buy ice cream and people are drowning? True or false? Clearly, this is laughable, right? We can understand that, yeah, even though both the statements of fact are true, the conclusion is not true. It clearly is not true. So, what just happened here? We put the data within our analysis, and the system told us about the correlation between these two facts. And we are saying, I absolutely refuse to accept that. So, artificial intelligence is stupid, and causal reasoning will not fix it. Frontiers in Psychology, January 2021. So we're not the only ones who are frustrated. Wait a second, what just happened? I did not expect to get that result that ice cream would cause people to die or to drown. Clearly, something is not working. Look at another publication. Using artificial intelligence to predict behavior can lead to devastating policy mistakes. Stanford School of Innovation, 2020. So, something is wrong. Let's figure out what's wrong. Let's continue. Let's introduce another concept, causation. The act of causing something. You know the cause and effect? This is related to cause and effect. When one event leads to another event, or when one event causes it to occur, or the capacity of one variable to influence another variable. Causation, friends, is not correlation. So this is really in a nutshell. That's one of the core themes of this presentation here. That artificial intelligence is an automated tool that you could deploy, give it the data that you had, and it helps you identify the correlation between the different fields, the various fields. It's a great insight, but don't just take it blindly. It doesn't tell you what the causation is, right? It doesn't tell you that if one event is actually causing the other event or not. It's just stating the fact. It's just saying, hey, listen, I found very high correlation between the ice cream field, if the person has, if the ice cream sales are high or low, and the deaths are high or low, and I'm saying there's a direct correlation between the two. Correlation, yes, but definitely not causation. And you're looking for a cause. You're looking for to reduce the areas for why in the first example why your customers are why your employees are leaving, right? So again, we have to be very careful about how we take the answers. So back to our problem now. Employee turnover is very high. What do we do? So the machine learning algorithm, it studies the relationship, correlation, as we just said, between the status field and all the other variables. Fine. We just understood this as well. And attempts to identify the employees who are likely to quit. So again, why is this important? We earlier talked about the impact to the organization for what happens when people leave. So again, they're trying to counter that, they're trying to stop that. So lots of benefits. Likely to quit is the key here. Look at the second statement again. It attempts to identify the employees who are likely to quit. That really is the key, likely to quit. That means the model is giving you not definitely going to leave or will never leave. It simply doesn't know that. It's just giving you a percentage of something happening. Likely maybe 60%, 70, 80, 90, 95%. It's all a scale, right? So saying person A might be more likely or higher percentage to leave as compared to person B, but nothing is guaranteed. Obviously, we all can understand that. So let's go back to the first definition we had for artificial intelligence, that it's a very specific type of technology that attempts to replicate a human thought process. It builds its intelligence by absorbing materials and observations and uses this intelligence to make important forecasts and inferences. So again, let's highlight the point here. Important forecasts and inferences. It's a forecast, just like the weather forecast for tomorrow. It's a forecast. It's not a guaranteed thing. So where would you use this kind of an analysis? Again, we just went through this question, which employee is likely to quit? So why is this important for you? For you to say that, okay, if I know that employee John or Sally or Susan is likely to quit, then maybe you will do something. If you want to hold on to them, if they've been valued employees, they contribute very well to your operations and your processes, and you want to retain them. So maybe have a one-on-one talk with them, figure out what maybe their concerns. Maybe look at the salary, maybe look at the job requirements that they have, maybe figure out how they work and what improvements they might have. Maybe they have some ideas. So whatever it is that you would need to do in order to hold on to these employees, that's what you need to do. The model is now been able to identify which employees are likely to leave. So at least you've got something to work with. So you're able to maybe approach them and help them stay on board. Similar to employees, what about your customers? Which customer who's currently coming to you, giving you, supporting you with their money, they're trusting you, but which one of them is likely to stop buying from us? Likely to churn is the terminology that we use in business. So it's a business jargon. So how do you know? Again, just by looking at the data, you look at the past purchasing habits. You look at, is the purchasing levels declining? Are the quantities declining? Maybe they're spending more time. Maybe they're going out of the town. So if there's a physical store, then they will not be coming no matter what, right? So again, you're trying to get the data to tell you which customer is likely to stop buying. So therefore, if you could be proactive in your approach, you could approach the customer and maybe give them a better coupon, maybe adjust the prices, maybe do something, at least talk to them, right? At least figure out what's likely to happen. So therefore, you might want to be proactive and try to figure out what you could possibly do to hold on to them. Let's look at some other examples. What else you could do with this kind of an insight? You own or you're manager of a fleet of buses or trucks or planes, and every morning you dispatch. Let's say you've got, we'll keep it a very simple example. Let's say you've got 10 buses, and out of the 10, 7 are supposed to go out every day. That's what your everyday's fleet looks like. You need to know which 7 are in a good shape and which 3 are likely to fail, because you don't want to put something out on the road that's likely to fail. And why is that? Because the cost of recovery from a failure when something's already in flight is much higher. If you knew ahead of time, you will just say that, okay, bus 1 keep it back and bus 2 let it go, and let the bus 2 go and hit the road. Whereas if bus 1 actually goes out there, it fails on the side of the street, then the cost, we now have to send an extra bus with an extra driver to go to that location, transfer the people on the bus, or transfer the packages you had got on the bus, and then tow the first truck or the first bus back to the service center. Again, it's a very, very expensive proposition. So you really want to know upfront which bus is likely to fail, or which plane is likely to fail. So again, this kind of an analysis is extremely crucial, extremely important for these companies to be able to entertain. We asked this question earlier: what's the probability of rain tomorrow? So again, looking at the weather pattern, looking at the flow of the clouds, of the weather conditions, what's going on out there, the system is able to make the external factors and make an intelligent determination. Again, it's never guarantee, but again, it's a forecast. Which color schemes on the new website is likely to produce better results? Again, even though we could do A/B testing to actually test it out by putting it in front of people, but maybe the system may also be able to make an intelligent determination to see which color is likely to produce results in terms of the visibility on the screen, in terms of how other sites, other similar websites have done, how our previous A/B test results have yielded results, right? So it's able to do all of this. Maybe the system can give you an analysis. So this is a very important point for us to remember. High likelihood of an event is not a guarantee. Real life outcomes may be vastly different. Imagine going back to the earlier example, that when we said which employee is likely to leave, it didn't factor in the fact that some of the employees play video games at the end of the day, or they meet weekly and play a game of soccer or softball or any other sport, and they've got a good bonding between them, good camaraderie. So no matter how happy or unhappy they might be at work, but just because they've got something else going on the side, they would want to hold on to it. Or somebody whose parents live a block or two down the street from the office, and they want to visit them occasionally, so they know that if they change their job or move to a different town, they'll lose that. So even if they're not very happy in the position, they may still want to hold on to the company. So again, your model said high likelihood of the employee to leave, but in reality that didn't happen. So again, high likelihood is not a guarantee. Let's take this example. Is this new movie expected to be a hit at the box office? So you're a movie studio, you've just did a very expensive blockbuster, you're hoping, you're about to release it. What's the likelihood for the movie to be successful? There are so many factors: internal factors, external factors, the level of competition, even the economy. You really never know. You could have the biggest names, stars, performers, and the movie could flop. And you may have absolutely nobody's in the movie, and yet the movie becomes a super hit. All kinds of scenarios are possible. So again, just because we have a model, just because we've got prior data, when we ask the data what the model could represent, again, just because it's able to give you a probability, don't think that it's absolutely going to happen. Another question: is my marriage likely to last or not? Again, we know that marriages do fail, even though you might have the best intention, the best modeling, the best compatibility, everything, and yet things do happen. So again, just a point to remind here that the human intervention is important, and that in a way I'm sort of jumping ahead. It's one of the critical takeaways. So let's see what they are. The algorithm can predict the likelihood of something taking place. It's not a guarantee. Again, we've said this multiple times and we'll keep saying it many more times. Human intervention, therefore, is really important. It's required to devise any corrective measures or strategies. And a model learns by absorbing all the material is provided. If there's bias in the data it uses or in the human actions it attempts to mimic, guess what? The model would also have bias. And we'll just see an example of that. Let's see an example of bias in the data. Back a few years ago, Amazon said that we have to go through thousands and thousands of resumes that we receive on a weekly or monthly basis. Very expensive for us to assign humans to go through the resumes and pick the ones that we really want to maybe do a phone interview, phone screening. So what they did was they built an AI system in-house. They built an AI system which tried to monitor how humans are evaluating the resumes, what they highlight, what are pluses, what are minuses, and it began to mimic what the humans were doing. So they built a model. They built a system that said, okay, just feed all the resumes to this system, and it'll tell you that of everything you fed me, this 12%, 15, 18, for 25%, whatever the actual percentage was, let's call them for a phone interview, or let's take them to the next level of the hiring process. Rest of them they just did not. They said just set them aside. They're not our target candidates. And yet, after a few months of being in production, they scrapped this project. So Amazon, the news from 2018 October, Amazon scraps a secret AI recruiting engine that showed bias against women. Another news around the same time. Amazon built an AI tool to hire people, but had to shut it down because it was discriminating against women. And why is this? This is because of for something we just had a moment or two ago. We just wanted to point you back to this, that you provided the context, you provide the system the information, and it's trying to mimic, it's trying to imitate what you do. So guess what? If you have a bias, if your system, the people who are looking at the resumes, if they have a bias, guess what? Your system acquired the same level of bias. So it doesn't mean that AI is bad. It simply means that it was given bad data, bad training data. So this is again another big reminder that even though it flopped at multiple levels, but it doesn't mean that the AI effectively was bad. So Amazon's sexist hiring algorithm could still be a better than human. And why is that? Because let's say that we deploy something like this, and within a month or two, it just came back and said, wait a second, something is really wrong here. So it brought something to our attention, and now as humans, we are supposed to figure it out, and we're trying to improve the things. So that's really what everything, every system, every new methodology, every new process entails. We really must understand what is happening, and if something is working, great. If something is not working, why is it not working, and what do we need to do? So guess what? They had to make some changes to how it fed the data, and then they were able to continue. So again, so whether Amazon continued with this project or not, or they did another revised version of that, that's not the point. The point of this is that we realize that there might be a bias in the data, it might be very obvious, or sometimes it may not be obvious. So the whole notion of what we've said multiple times, it's a system giving you a likelihood percentage of something happening. Don't just go blindly by that. You need to apply your real life analysis on coming up with actual corrective measures and decisions what you're likely to do. So again, the critical takeaways is what we just talked about, and we really want to underline the fact that a human intervention is always required to devise any corrective measures or strategies. Okay, so thank you again for coming with us. For thanks for this short journey. It didn't take a whole lot of time, but we hope we've been able to explain the concept of what it is. Artificial intelligence just tries to mimic what we do, only tries to do it better, and it's much more efficient. It's able to take in a whole lot of more data than we could possibly do. If you go back to the earlier example we just went through, that the hiring process of the company and employees are leaving. Imagine if we have to go through a spreadsheet that has 150 columns and 10,000 records. How would you possibly a human, how could a human go through that kind of a data and come up with correlation between the fields? So that's what this tool is really good at, and that's what this tool should be used for. If you come back to this channel, the next lesson would be about taking the model and trying to understand the accuracy of the model. So in that case, we'll introduce these four definitions. True positive, that's when the model said something is going to happen and it actually did happen. So the model was successful. True positive. What about true negative? Another scenario where the model said something is not likely to happen and it did not happen. Great, success, right? And then there could be the area where the model did not succeed, like false positive, when the model said, wait, something is likely to happen, like in case of an employee, somebody is likely to quit. In reality, they don't quit. So again, whether you adjust the model or what happens. So in the next course we'll study that. And then similarly, false negative, when the systems predicted no and in reality it happened yes. Now again, if you imagine the implication of the last two, if you just give us a moment to explain what the implication could be. The model predicted yes and the actual outcome is no. So imagine you've got a fleet of buses. That's one of the examples we gave, and we said, okay, the model said this bus is likely to fail, and yet you send the bus out on the road and the bus did not fail. Okay, so what's the worst that would have happened if you had held the bus back and the bus would not have failed that day? So yeah, so maybe it was a failure that you maybe avoided that by holding the bus back. So again, there's minimal impact on your organization or on the business. But imagine the last point, the false negative. That could be bad, right? Imagine someone comes in for cancer screening. They go through the test, the radiology test, and you're looking at the scan, and the system says, no, I don't see any lesions. I don't see any cancerous growth. And in reality there is, and system just missed that. Imagine the impact of that. So again, these four ways to determine the accuracy of your model, they are really important for us to take the data what the system is giving you, put that into the real life, and try to understand what the implications would be. So in the next course we'll address that. And how would you so once you know what your situation requires, then how would you tweak the model based on the real life scenarios? So thank you again for coming with us on this journey. We hope you're walking away with a good understanding of what artificial intelligence is, and we hope to see you in the next course. Thanks again.